The sine rule, of course, allows us to solve certain situations, but not all situations. So we also have the cosine rule. So let's derive that one. Again, I'm going to drop the perpendicular height in. Now, using Pythagoras, we know that h squared would be b squared minus x squared. C squared will be h squared plus a minus x all squared. So subbing in for h squared, I now have b squared minus x squared. Expanding out the parentheses, now the x squareds will cancel. So I've got b squared plus a squared minus 2ax. So now I just need an expression for x. X over b is the cosine of c. Sub that in and we get our cosine rule. It's basically Pythagoras extended. So a squared is b squared plus c squared minus 2bc cos a. Or b squared is a squared plus c squared minus 2ac. Or c squared is a squared plus b squared. So when I say it's Pythagoras extended, the side opposite the, well, hypotenuse if you like, but the side you're trying to find in a right angle triangle is of course 90 degrees. And the cosine of 90, 0, thank you. So the 2bc cos part would be 0, and you get a squared is b squared plus c squared. Alright, let's do a classic example. So it's t we want to find. So for this one, t squared would be f squared plus m squared minus 2fm cos t. Sub in. And a bit of calculator work. Now remember, that's t squared, so don't forget to press the square root button. I've rounded mine to the nearest whole number because, well, the question had their sides to the nearest whole number. Now if I want to find an angle, some people like to remember a specific formula for the cosine rule. I'm not one of those. I still start with, oh well, it's angle f I want to find, so I'll write it as f squared being the subject, and then I'll just rearrange it rather than trying to memorize that each time. So a squared plus s squared minus f squared all over 2as. Substitute in. Now we don't have the same problem as we do with the sine rule, because of course acute angles, cosine's positive. Obtuse angles, cosine's negative. So the calculator can differentiate between acute angles and obtuse angles. And in fact, in this one, 6 squared plus 15 squared minus 20 squared, positive or negative? Negative. So we're expecting an obtuse angle here. And indeed we do. 140 degrees, 33. Here's a question where you think, oh, hang on, I'll use the sine rule. Oh, hang on, I've only got one angle, I can't use the sine rule. Oh, I'll use the cosine rule. Oh, hang on, it's the angles not opposite the side that I want to find. I can't use the cosine rule. But in fact, you can use the cosine rule. A squared is b squared plus c squared minus 2bc cos a. It's just that what I want to find is not the subject of the formula. So I'll get 3 squared is b squared plus 7 squared minus 2b times 7 cos 25. I end up with a quadratic. And it's an interesting quadratic. What multiplies together to give 40 adds together to give negative 14 cos 25. I wouldn't struggle too long because you're not going to come up with numbers. So we'll go to the formula. So we have b is 14 cos 25 plus or minus square root of b squared, so that's 196 cos squared 25, minus 4ac, so minus 160, all over 2. So I have two possibilities for b. And unfortunately, I don't have enough information to work out which particular answer it is. Remember, we know things like that the smallest side's opposite the smallest angle, the largest side's opposite the largest angle. I've got b, whether I take 5.85 or whether I take 6.85, is going to be the middle side. So there's no way of knowing. Without more information, there's no way of knowing. So there's actually two possibilities for this particular triangle. Okay, 'tis all from me today.